Okay, so the last section of the semester is Taylor and Maclaurin series. And how do you find a Taylor series or a Maclaurin series? Okay. So if a function f of x has a Taylor series.
Excuse me, Professor.
Yes.
Can you scroll up a minute? I just want to take a picture of the times and the dates in the rooms again.
No problem.
Thank you. I got it. Thank you so much.
You're welcome. Okay, any questions thus far about where we are? Okay. All right. So a function f has a Taylor series if you can write f of x is equal to the sum n equals 0 to infinity of the nth derivative of f at some value a, x minus a to the n all over n factorial. So this is a Taylor series for f of x about the point x naught equal to a, about x equal to a. If a is equal to 0, then it's called the Maclaurin series. Okay, so notice I need to be able to take infinitely many derivatives of f because this requires the nth derivative and n goes from 0 to infinity. Okay, so things that stop at, let's say, capital N equals to 12 may be a Taylor polynomial, but will not be a Taylor series. Okay, so let's find the Taylor series. So this is the process. I will do the easiest one first. Find the Taylor series about x equal to 0. So this is really a Maclaurin series for f of x equaling e to the x. So this is the easiest one ever to find. Okay. So you are going to make a table. So the first column of the table will be n. The next column of the table will be the nth derivative at x. The next column of the table will be the nth derivative evaluated at whatever a you've chosen. Then the last column will be the nth derivative at a divided by n factorial. Okay. All right, so the goal is to try to find a pattern. So if my function is e to the x, taking no derivative of it, I get e to the x. A for us is 0. So therefore, take e to the 0, that is 1. Okay, so this would be 1 over 1 factorial, which is just 1. Okay, so that's our first one. Oh my goodness. That went fast. Not for some of you, but for me, it went fast. Okay. First derivative. The first derivative of e to the x is e to the x. I take e to the 0, I still get 1. Oh, I apologize. Yeah, that's right. This is 1 over 1 factorial is 1, so I just get 1 again. Remember, 0 factorial is 1, so that's why I divided by 1 up there. The next one, n equals 2. The second derivative is e to the x. E to the 0 is 1. I'm going to get 1 over 2 factorial. Is there a question? Okay, let's go a little further. So let's get 3. The third derivative is just e to the x. E to the 0 is 1, so I'm going to get 1 over 3 factorial. So as I'm doing this, I can kind of get a pattern. It looks like I'm going to continue to get e to the x. I don't think anything's going to change. So let's say if I go down to n, I'm going to get e to the x. I'm going to get 1, and then I'm going to get 1 over n factorial. So it looks to me like my formula, here's my formula for the nth derivative. So the nth derivative at 0 over n factorial is simply 1 over n factorial. Okay. So now that means that my function f of x, which is e to the x, we said is the sum n equals 0 to infinity, the nth derivative at 0 over n factorial times x minus 0 to the n. Well, this piece is we just found. So that simply becomes this n equals 0 to infinity of 1 over n factorial times x to the n. There's the first Taylor series. So now we know e to the x is the sum n equals 0 to infinity of x to the n over n factorial. So that's going to be 1 plus 1 plus 1 over 2 plus 1 over 3 factorial plus 1 over 4 factorial. Oh my God, I forgot the x's. Scratch. That's 1 times x to the 0 plus x times 1 plus x squared, and it is over 2 factorial, plus x cubed, it is over 3 factorial, plus dot, 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 plus x to the n over n factorial, plus dot, dot, dot. So now we have found our first power series representation of the day. Okay. Let's look at the next one. So find the Taylor series about x equal to 3 for f of x equaling 1 over x. Okay, draw the same table. So we start off with n. Then we need the nth derivative at any x. Then we need the nth derivative at 3, because that's what we're trying to find. And then we'd like to find the nth derivative at 3 divided by n factorial. All right, so the first one is n equals 0. The function itself is 1 over x. So now when we put in 3, we're going to get 1 over 3. And we'll deal with that last piece later. I'm going to do this next piece. So we have 1. When I take the derivative here, I'm going to get negative 1 over x squared. And for me, negative 1 over x squared, then I'm going to get negative 1 over 3 squared. Okay. All right. So now I'm going to get the second derivative. So that's going to give me positive 2 x to the negative 3. Then when I come over here, I'm going to get 1 over 3 cubed. Okay. The next one, 3, when I take the derivative, I'm going to get negative 3 times 2 times x to the negative 4th. So now let's be clever here. 3 times 2, that's starting to look like a factorial. I'll just write it as negative 3 times 2 right now, over 3 to the 4th. And we're going to go, just have a little bit more we can do before we're so rudely interrupted by the end of class. Okay, let's do one more because I really am feeling like it's a factorial there. So when I do 4, I'm going to get positive 4 times 3 times x to the minus 5. Now I'm pretty sure it's a factorial. So now I'm going to say this looks like 4 factorial over 3 to the 5th. Okay, so now when I come over here, I have 1 over 3, and then it's over n factorial. 0 factorial is 1. So I'm going to get 1 over 3 times 1. This is going to give me negative 1 over 3 squared. And when I divide by n factorial, I'm going to get a 1 again. Here now, I'm going to get, oh, I forgot my 2. I get my 2 over 3 cubed. But I'm going to multiply by 2 factorial. Here, I'm going to get 3 factorial, negative 3 factorial, divided by 3 to the 4th, but I have to multiply by 3 factorial. Okay, so what I want you guys to do is I want you to try to go back and recreate what I've done. Look at this and see if you can see a pattern. If you can see a pattern, write out the formula. Hopefully we will be able to get there. We'll definitely be able to get there tomorrow.